In last class, I have discussed about sorting techniques, and the most two basic sorting techniques are we have already discussed, that is bubble sort, then the modified one, modified bubble sort, and then the next is selection sort, which is more practical one. And today we will try to discuss what are the drawbacks of these two sorting techniques, and then a more advanced sorting technique. So what are the drawbacks? Now, the first drawback of bubble sort or selection sort is that we required the whole set of elements, together. What is the meaning of this? So suppose I want to sort some set of elements. Suppose this is my set of elements, x1, x2, like this, up to xn, and I need to sort them. So I will put it in an algorithm, that is the sorting, and then I will get it in sorted order. Suppose the sorted order is x1, x2. This is the sorted order. Okay. See, both in bubble sort and selection sort, if I want to perform the sorting, I require the whole array. Without this whole array, it is not possible. Suppose I have three elements. Suppose I have 22, 33, 11, these three elements. And I have performed already one sorting technique I have performed on this, and my sorted elements are now this. Now suppose suddenly one new element came. Suppose the new element is say 20. Then again I have to perform on this unsorted element. See, on this unsorted element, again I have to perform a sorting technique. So in case of both bubble sort or selection sort, we require the whole set of elements together. But see, one particular situation. Suppose I am working in an online situation or real-time scenario. I am working in a real-time scenario, or you can say online scenario, where data is coming in a chunk. A set of data is a chunk of data. And I have to wait for the next chunk. Suppose after some time a next chunk is coming. So if it is a real-time scenario and I have to sort all my data, then it is very difficult to perform the sorting. This bubble sort or selection sort. Why? Because the data is coming online. Sometimes data is coming, sometimes nothing is coming. So I have to wait for the whole set of array if I want to perform bubble sort or selection sort. Otherwise, if I perform bubble sort, whatever I have, then in the next time for few new elements, again I have to perform the same sorting technique. So in real-time scenario or online scenario, it is not possible to perform again and again the same sorting technique, bubble sort or selection sort. Okay, that's why a new kind of sorting has been developed, which is called insertion sort. So the main reason of this insertion sort is to apply the sorting technique in real time. What is the meaning of real-time sorting? Real-time sorting means if I have, suppose there will be 100 elements. or 100 data, and I have to sort this 100 data. But due to this real-time scenario or this online scenario, at the first time second or time lapse, I got only 55 elements. If I want to apply bubble sort or selection sort, then I have to wait for the total 100 elements. But if I am applying insertion sort, then what I can do, I can apply the insertion sort on this set of elements. Then when new set of element will come online, one by one, I can make them sorted. That is the advantage or beauty of insertion sorting. The same technique is used if you have played the cards. You see, there are means the collection of cards. Suppose I am playing cards with some of my friends, and I am going to distribute the cards. Then I will distribute the cards to my friends, 1, 2, 3, and this is myself. Suppose this is myself. I am distributing the card in the circular manner. Okay. Now you have seen that some of the person will collect the cards when it is coming. And some of them will collect the cards after the completion of the distribution. So there is two types of data collection. One is data is collected on real time. One data is coming, he is collecting. And there is another type of collection where the person is collecting the data after the total distribution is done. Suppose I am distributing the card, and after distributing the 13 cards, this person 1 is collecting the card. This person 2 is collecting the card online. One card distributed, he got it in his hand. Then the next card distributed, he will got the card in his hand. So in this way, he is performing a sorting. Similarly, he is also performing a sorting. See, after collecting all the cards, he will make them sorted. All the spades in one side, all the diamonds in one side. Diamonds are in sorted order. The Tekka, then Saheb, Bibi, Golab. He or she is just sorting those cards. One person sorting the cards after getting or after the completion of the distribution. Another person is sorting the cards when it is given. Means the process is running real time. So this sorting, the person who is doing it in real time, one card is coming, he is collecting, is performing actually insertion sort. This person, after the whole distribution, when he is doing the sorting, he is either doing selection sort, or else he is doing selection sort. So this is the insertion sort. So insertion sort, sometimes called curve sorting, and sometimes also called online sorting. So I hope why this insertion sort is called curve sorting or online sorting, it is clear. And so in real-time scenario, we will prefer insertion sort. See, there are 4 to 5 different sorting techniques in your syllabus, and you will see each and every sorting technique have a different flavor. Each and every sorting having its advantage in a particular scenario. Selection sort, which is practically more useful. This insertion sort, when I am doing something in real time or online, I want to perform sorting, this insertion sort is the best one. Whatever be the time complexity, but you have to understand the scenario where I have to implement those sorting. It is not that I have to always see what is the time complexity. Is it taking too much time? That is not the criteria for different sorting techniques. You have to choose in which scenario I have to implement which sorting technique. That is the most important. So this is the beauty of insertion sorting, that it is the only sorting which is applicable in case of online. I will show you one sorting which is not included in your syllabus, that is radish sort. That is very interesting. In case of radix sort, the beauty is you don't need to remember which number is greater than the another number. So you don't have to, you don't have, if you don't have the idea of mathematics, still you can perform the sorting using radix sort. That is the beauty of radix sort. The beauty of quick sort is it is quick. When it is worst case, it will give you the best time. That is the beauty in quick sort. Okay, so now let us discuss the algorithm of this insertion sort. So we have the stage is set, is why we need insertion sort, where we should apply insertion sort. Now we will discuss that the insertion sort, how it will perform. So I have already told that it is almost similar to the collection of card in at the time of distribution. Collection of card at the time of distribution. So the first card is distributed. Suppose the number in the first card is say 50. So do you need to sort the first card? No. The simple answer is no, because single element is by default sorted. Next element, suppose the next element or next card is suppose 20. Now see, this 20 and it is a default criteria that we are going to sort them in ascending order. Okay, so the next card is 20. So what is the position in ascending order for this 20? It should be before 50. So what I will do, I will insert it in this position. So it becomes 20, then 50. Suppose the next element is say 10. Okay, now I will again check what should be the position of 10. The position of 10 is before 20. So I will insert it in this position. So after this, it is sorted. See, this is the beauty. After this is, now suppose the next element is 30. New element came, that is 30. So what should be the position of 30? See, it must be in between 20 and 50. So I will insert it in between 20 and 50. So now my sorted array is like this. So in case of card, I will do it like this. Now see, the beauty is, suppose I have only these 4 elements. Rest elements not yet came. So what I have only these 4 elements. And see, this 4 elements is already sorted. So then whatever next element will come or not come, that does not matter. If new element come, what I will do, I will just put it in its proper position. Suppose the new element is 15. So what I will do, I will put it in proper position, or I will insert it in its proper position. And again, my array is in sorted order. See, I don't need to apply the same sorting technique for whole array again and again. If it is bubble sort, a new element came, then again I have to perform the same algorithm, compare adjacent element. If I have to perform the selection sort, I have to select the minimum, then I have to put it in the proper position. See, this is the beauty. Whatever I have, that is already sorted. If there is something new, that will be inserted in sorted order. That is the, so you can write it like this. Whatever you have that is in sorted order, if any new element will come, then that will be put in its, or better put, you can use insert, that will be inserted in its proper position. So this is the actual algorithm or idea of insertion. Now this is in case of card. Now if it is in case of array, now we have already seen, if it is array, so it means I have all the elements. If it is array, I have all the elements, but I will consider the elements in such a way that I will consider one element at a time and move forward. Suppose I have this set of elements. Suppose let us consider the 5, 3, 1, 6, 4, 9, 8. These are the index values 0, 1, 2, 3, 4, 5, 6. So what I will do, I will consider one element at a time and move forward. So I will start my insertion from this position. Why? Because first element is by default shorted. So it means now only I will consider that there is only this element is present, and I have to insert this new element in its proper position. In my eye, this one is no more exist, or this is not present. This part is not present. I have only this element and I have to insert it in this element. Okay, so what I will do, I will compare this element with this element. If this element is greater than this element, then what I will do, I will shift. See, in case of array insertion, if you remember, array insertion is actually done by shifting. So I have to shift. If I want to insert an element in any position, suppose I have already 11, 22, 33, 44, 55. I have to insert say 30 in this position. What I will do, I will shift all this element, then I will insert this new element. That is the logic of insertion. So when I am inserting, so what I will do, I have to first, what I will do, first I will store 3 in a temporary variable. Why? Now you can ask, why sir I will put it in temporary variable? Because when I am shifting this 5 into this position, this 3 will be overwritten. So that's why I am storing the 3 in a third variable. Now 3 is stored in third variable. Then I am comparing this third variable temporary variable with this 5. 5 is greater than this, so 5 will be shifted into this position. This means 3 is now overwritten and now 5 came here. Now I will stop. Why I will stop? Because there is no more element. So the next thing is I will put this temporary element into this position. So in this way, 3 will come here, 5 will come here. Okay. Now the next element, I will consider the next element. What is the next element? Next element is y. So again I will put the next element is 1. So again I will put 1 into this temporary variable. Then I will compare this with 5. 5 is greater than 1, so 5 is shifted. 5 is shifted means now 5 is in this position. Then 1 will compare with 3. 3 is greater than 1, so 3 will be shifted. So now this 5 is overwritten by 3. Now there is no more element, so temporary variable will be assigned into this position. So 1, then 3, then 5. Okay, now the next element 6. So the next new element is 6. So first I will store 6 in a temporary variable. Then I will compare it with 5. See, in this case, 6 is greater than this element. So no more shifting because 6 is in its proper position. So what I will do, I will put it as it is. Next, so after this, it becomes 1, 3, 5, 6. What is the next element? Next element is 4. Again, first I will store it in the temporary variable. Then this temporary variable will be compared with first 6. 6 is greater than, so 6 is shifted. 6 will come into this position. Then 4 is compared to 5. 5 is greater than, 5 is shifted. So 5 will come into this position. Then 4 is compared with 3. It is not greater. 3 is not greater than. So what I will do, I will put 4 into this position. Okay, so 4 will come here. So now my sorted array is 1, 3, 4, 5, 6, and so on. So this is the whole idea in case of array. See, in case of card, it is very easy to insert. But in case of array, when we are inserting, we have to remember, we have to shift the elements. And we have to make a free space. So that's why we are shifting. So we are comparing, we are shifting, and then we are just putting or inserting the element. See, you can do it in this way also. Suppose 5, then 3, then 1. This is my initial array. So first 3 and 5 is compared, says 3 is less than, so this 2 will be interchanged. This is also can be done. This 2 will be interchanged. So now it is sorted. The new element, next new element is 1. So first 1 and 5 is compared, 5 is greater than, so this 2 will be shifted. Not shifted, this 2 will be interchanged. So what will happen? 1 will come here, 5 will come here. Then 1 is compared with 3. Again 3 is greater than, so this 2 is interchanged. So 1 will come here, 3 will come here, 5 will come here. So in this way also you can do it. But see, if you see the name of the sorting technique, it is called insertion. So insertion is not same as interchange operation. So that's why this algorithm is better than this algorithm. And see, if you perform this interchange operation, a single interchange operation requires 3 statements. T equal to A of x equal to A of y equal to t. So you have to write 3 different assignment statements, and it will take a little bit time. So it is better to perform it in this way. Or you can do it in this way, but better you do it using this concept, because this is the proper insertion operation. This is not proper insertion operation. Okay. Now let us try to implement it in some sort of say pseudo code. Okay. So what I am doing, so this is the actual. So what I am doing, I am starting the array from the second element. Okay. So I will start the loop. So I will start the loop from the second element. It means index value 1, and it will move up to the end. So I less than n, then I plus plus. Okay. Then so this is my element. So this for loop will take each and every element from the second element to the end element. And then what I am doing, I am comparing this element with the previous one. See, for 1, I have to compare it with the previous 2. For 6, or say for 4, I have to compare it previous 4 elements. So I have to compare the next step. I have to compare the new element with the rest of the previously sorted element. Is it clear? I have to insert the new element into the previously sorted elements. Okay. So I have to repeat the same things, comparison. So the first thing that I have to do, I have to store my new element into a temporary variable. So I am writing t equal to a of I. So I hope this is clear. Okay. Next, I am comparing this temporary element with the previous all the element. So what I will do, I will start a for loop again. Okay. And from which element I will start? See, if I am going to insert 1, then I will start comparison with the previous one. So if this position is ith position, then I will start from I minus 1th position. So j will start from I minus 1th position. The next thing is, in the worst case, if my suppose my elements is like this 1, 2, 3 already there, I have to insert the new element 0. Then I have to compare with all the existing elements. So I will move up to the last index value. So what is the last index value? Last index value is 0. So this is the worst case. Okay. So my j will move up to 0. So j is greater than equal to 0. I have to check. Now see, there is another condition which I have to check. There are 2 different conditions simultaneously I have to check for this insertion. Why? See, for particularly for this example, if 1, 2, 3 already present and a new element 0 will be inserted, then I will stop when, and what are the index values? Index value is 0, 1, 2, 3. So this is a new element, I, index value. I will start comparison with j, which is initialized with I minus 1. Then it will compare with, and so gradually j will be decreased, first 2, then 1, then 0, and then it will stop. So in this example, j will stop when j becomes 0. But see, there is another example for this one. There is 1, 3, 5, 6. Already this is the existing array, already sorted. The new element is 4. And what are the index values? 0, 1, 2, 3, 4. So this is my new element. First I will compare it with 6. Okay. Then I will compare it with 5. Then I will compare it with 3. So I will start from this position. J will start from this position. Then J will be decreased. See, after this, when J reach in this position, after this, no need to compare because 4 is greater than 3. So in this case, I don't have to move up to 0 value. So it is not always true that I have to move up to 0 value. Sometimes I have to stop before. When I will stop, see, it depends on the comparison. Comparison with what? Comparison with temporary variable and the jth element. I hope it is clear. Which element is compared with which element? This t temporary element actually compared with this jth element. And I will stop if the jth element is smaller than the temporary element. See, this is temporary element 4. This is jth element. Jth element is now greater than. So I will move forward. Now this is jth element. This is greater than temporary element. Move forward. Now this is jth element. This is smaller than temporary element. So I will stop. So the stopping of this particular loop, this for loop is basically for what? This for loop is for comparison. This for loop is for each and every element. Okay? And this for loop is actually for insertion. Using this for loop, I am inserting the new element. So for this for loop, there will be two different criteria for stopping. One is either if it is become like this, if I becomes j becomes less than 0, I will stop, or this another criteria. For that, I will stop this comparison. Okay, I hope it is clear. So in this particular for loop, there will be two different conditions, and I will put one and get for this two different condition. The first condition is normal loop condition. When I will stop, see, I am decreasing the value of j. So when j becomes 0, I will stop. And there is another criteria which is for the comparison of temporary variable with the jth element. So I'm comparing temporary variable with the jth element. Okay. So this is for loop continuation. So when this loop will continue, if I will continue the comparison if my new element, or you can say the temporary element, is smaller than the the already existing element. If my temporary element is less than, see, when I will stop, see, in this particular case, in this, when the temporary variable 4 is greater than this, I will stop. So when I will continue, if temporary variable is less than a of j, so I have written it like this: t less than equal to a of j, I will continue the loop. So these are the two different conditions, condition 1 and this is the condition 2. Remember, when these two are true, then only we can move forward. Okay, so the next thing is the j will be decreased, j minus. So this is my whole for loop. Okay, I hope it is clear. So I have started from the previous element for comparison. Either I will stop when it becomes 0, or I will stop when t becomes greater than a of j. And with each increment, with each iteration, I will decrease the value of j, because I will move in the reverse order. Okay. Then what I will do, when it is compared with this, what is happening? When t is compared with 6, what is happening? This 6 is copied into this position. So 6 is the position of jth element. Now jth element is copied into the next position. So I can write it like this: A of j plus 1 is overwritten by A of j. I hope it is clear. See, the 6 will be copied into this position. If this is the location of jth element, then it will be copied into j plus 1th element. So I have written it like this: jth element is copied into j plus 1th element. Okay. And after doing all this thing, when I will come out from the loop, the last thing that I have to do, I have to copy the temporary element in its proper position. So how to copy the temporary element in its proper position? I will write it like this: A of j plus 1, because j will be moved forward one's position. So I will write it j plus 1 equal to t. So this is the whole insertion sort idea. Okay, let us write it again, and we will check using one simple example. So the first for loop, again I am writing the same code. So the first for loop, I equal to 1, I less than n, I plus plus. Then inside the for loop, I will store it into a temporary variable. Okay, then I will start the next for loop for comparison. The comparison will start from I minus 1th element. There will be two different conditions: either j equal to 0 and either t is less than a of j. If these two conditions are satisfying, then it will move forward, and with each iteration j will be decreased by one value. Then a of jth element will be copied into a of j plus 1th element, and after coming out from this for loop, I have to put the temporary element in its proper position. So I will write it: a of j plus 1 equal to t. So this is the insertion sort. Very simple code. And you have seen that I have converted this code from the actual algorithm example. Okay, now I will dry run this code for a particular example. Suppose I have 4 elements. I'm taking a small size array: 0, 1, 2, 3. Okay, let the elements are like this. Sorry. Let the elements are like this. Suppose the first element is, say, 5. Then the next element is 3. Then the next element is 1. Next element is, say, 2. Okay. So let us write it 4. Okay. So this is my set of elements. So what is the initial value of I? Initial value of I is 1. Okay. So what is the value of n? Here the value of n is 4. So this is 4. So 1 less than 4 satisfying. So the value of t is a of 1. A of 1 means 3. So my new temporary new element is 3. Okay. Then j will start from which position? J will start from I minus 1. I minus 1 is 0. Okay. Is this one satisfying? Yes. J greater than equal to 0. Now check this one. What is in a of j? In a of j it is 5. So now it is 5. And temporary is 3. So this one is also satisfying. 3 is less than this. So what I will do, I will copy the a of 0 into a of j plus 1. So this is the position of a of j plus 1. So a of 0 element will be copied into a of j plus 1. So 5 is copied into this position. Then j minus minus. J minus minus means j becomes minus 1. Now see, this condition is not satisfying. For this for loop, this two condition must be satisfied. This one is not satisfying, so it will come out from the for loop. Okay, and then after coming out from the for loop, what it will do? A of j plus 1. What is the value of j? J is minus 1. So a of j plus 1 becomes 0. So a of 0, t is copied into a of 0. So this is the position of a of 0. So t is copied into this position. Okay, done. Then For the next iteration, I plus plus. So I becomes 2. Okay. And 2 is less than 4, satisfying. Now what is the new temporary variable? A of 2. A of 2 is 4. So the new temporary variable is 4. Now j will start from which position? I minus 1. So 1. J will start from this position. So j is now in this location. J greater than equal to 0, satisfying. Now move into this. What is the temporary variable? Temporary variable is 4. A of j is 5. 5 greater than 4, satisfying. So what I will do, I will copy the A of one element. Now j is 1. A of one element into A of 2's position. A of one element is copied into A of 2. So this is copied by 5. Now j minus minus. So j becomes 0. J satisfying this one. Now what is temporary? 4. What is A of 0? A of 0 is 3. Is this satisfying? No. This is not satisfying. So since it is not satisfying, it will come out from the loop. And what is written here? A of j plus 1. What is the new value of j? 0. So it becomes 1. So A of 1. So this is the position of A of 1. See, A of 1. So I will copy the temporary element into this position. What is temporary element? 4. So 4 will be copied here. Got it? So 3, 4, 5 shorted. Next iteration,